So next we're moving on to linear systems and matrices. So these I would say are probably going to be the easiest types of multiple choice questions because you don't even have to like work it out to solve. You can just take the answer choices, plug them into both equations and see if it works. But we're going to work it out anyways. So for number 3, we have to solve the system by substitution. So what should I do first? I'm going to add y to the other side. I want to solve this one for x because it'll be easier to plug in into my first one. So I get x is equal to 3 plus y. So this is what I'm going to substitute into x in my first equation. So 4 times 3 plus y minus y squared is equal to 7. Next, I want to distribute. So 12 plus 4y minus y squared is equal to 7. And then what should I do? Subtract 7 on both sides. So I get 5 plus 4y minus y squared is equal to 0. Then what? Not FOIL, but factor. But you have the right idea. So I'm going to put this in standard form. So I have negative y squared plus 4y plus 5 is equal to 0. I like to factor when my leading coefficient is positive 1. So I'm going to divide everything by negative 1. So just change the signs of everything. So this becomes positive y squared minus 4y minus 5 equals 0. Now what are two factors of negative 5 that add to negative 4? Negative 5 and 1. So then we have y minus 5 and y plus 1. So what do we get for our y's? 5 and negative 1. So I have 2 solutions for y's. So that means I'm going to have 2 solutions for x's. How do I find what the x value is? I'll plug it into the bottom equation. You can plug it into either one, but the bottom one's going to be easier to work with. So I'm plugging 5 into y. So it'll be x minus 5 equals 3. Add 5 to both sides. So x is equal to 8. So we add 5 to both sides.
You have to plug them both in?
Yes, we have to plug them both in. So then we would plug in negative 1. So this would be negative 1. Which turns into a plus 1. Subtract 1 on both sides, we get 2. So then our answer would be written as a coordinate point. So x first, then y. So it'll be 8, 5 and 2, negative 1. 5 we have to solve by elimination. So we always want to pick a variable to eliminate first. I can't tell if that's a plus 4 or a minus 4. I think it's a minus. Did you get fractions when you treated it as a plus? Okay, let's treat it as a minus. So let's say that's a minus 4. So what variable do you want to eliminate first? The x's, y's, or z's? I like the y's better, but you can pick whatever one you want to first. I think the y's will be a little bit less work. No, not with matrices. We're just using elimination, so combining the equations. So out of my equations 1, 2, and 3, which 2 do you want to combine first? 1 and 2, perfect. That'll eliminate the y's right off the bat. So if I combine 1 and 2, 3x minus 2y plus z is equal to 0, and 6x plus 2y plus 3z is equal to negative 2. So add these together. We get 9x, the y's cancel, plus 4z is equal to negative 2. So I want to pick 2 more and combine those. Which other 2 do I want to combine? 2 and 3. Yes. Will my y's cancel if I combine 2 and 3?
No, you have to multiply -3 by 2. -2 by 2.
So I'm multiplying the entire second equation by 2. So my new second equation becomes 12x plus 4y plus 6z is equal to -4. My third equation stays the same.
Wait, which one did you multiply by what?
The second equation I multiplied by 2. So now I can combine. I get 15x, the y's cancel, plus 11z is equal to 1. What do I do next?
You take your 2 new equations.
I take the 2 new equations and combine those. What variable do I want to eliminate here?
You don't have to do a specific one, you just choose,
Right,
right?
x or z, pick one.
Z.
All right, let's eliminate z. So our least common multiple would probably be 44. So I have to multiply this whole equation by 11, and I'll multiply this whole equation by 4. So this will be 99x. Oh, I'm going to multiply it by -11 because I need one of them to be negative. So negative 99x minus 44z is equal to 22. And then when I multiply the second one by 4, I get 60x plus 44z is equal to 4. Combine them together. So the z's cancel. I'm left with negative 39x is equal to 26.
You get a fraction either way, right?
Yeah, we get a fraction. So divide by negative 39. So 2 over -3, perfect. And then we would have to just use back substitution to solve. So I would take x, I could plug it into either one of these 2 equations down here, find z, and then take z and plug it into the original up here. And you would plug x into the original. So let's take a look at 13. We have to find the inverse for our 2 by 2 matrix here. I'm going to do it on the side here. So I have 2, 3, -1, and 0. What's the first thing I have to do to find the inverse? So I flip the majors and negate the minors.
Which one's your major, which one's your minor?
The one that starts in the upper left-hand corner is your major. So like the first number, that's your major. So we flip the majors, so that'll be 0 and 2, and negate the minors, so -3 and +1 now. And then what do I have to multiply it by? One over the determinant, which our determinant is the majors multiplied together, so that would be 0, minus the minors multiplied together. So that would be -3. So that turns into 1 over 3. So we just multiply 1/3 to everything. So 0 times 1/3 is still 0. -3 times 1/3 would be -1. 1 times 1/3 would be 1/3. And 2 times 1/3 would be 2/3. So this would be our inverse. For 17, we have to use Kramer's rule to solve. Remember, your final's multiple choice, so you can solve it whatever way you want to. But Kramer's rule is finding the determinant of the x, the determinant of the y, and the determinant, just like of x's and y's, the whole thing.
So it took like a lot of room to do on that matrix test.
Right. But with a 2 by 2, it's a little bit easier. So when finding the determinant of the x's, we plug the answers into our x column. So that would be 3, -1 in our first x column. And then the y's would be -2, 4. Remember the term determinant, we just multiply the majors and then subtract the minors. So 12 minus 2, which would be 10. To define the determinant of the y's, we replace the y column with the answers, so that 3, -1 would go in the y column, and 2, 1 would go in the x column. So multiply the majors, get -2 minus 3, which would be -5. And then the determinant of the whole thing is just the part with our coefficient. So that would be 2, 1, and -2, 4. So multiply the majors, we get 8. And the minors, we get -2. So this would be 10. It goes on the bottom. So it'll be d sub x over d, comma, d sub y over d. So d sub x is 10 over 10, and d sub y is -5 over 10. So 1, comma, -1/2. Let's take a look at 14. So a couple different ways we could do this. We can use the formula, or we could just plug in 2, 3, 4, and 5, and then add them all together. So if I plug in 2, I get 4 times 2, which is 8. Plug in 3, 4 times 3, which is 12. Plug in 4, 4 times 4 is 16. Plug in 5, 4 times 5 is 20. And then we just add all of these together. So that would be 56. So we can do 23. They're pretty much the same. So our formula for infinite sum is a sub 1 over, Matt, you said 1 minus r? So a sub 1 is our first term. So if I were to plug in 1 into this k, this would be 2 times 0.5, which would just be 1, over 1 minus r, which r is whatever has the exponent. So here it would be 0.5. So this would be 1 over 0.5. 1 divided by 0.5 would be 2. All right, so 37. 37 and 38 are the same, just different numbers, kind of. So we have to find the formula for a sub n for the arithmetic sequence and find the sum of the first 25 terms of the sequence. So our general formula is a sub n is equal to a sub 1 plus n minus 1 times d. So plug in everything we have. We have a sub n is going to be equal to a sub 1 is 100 plus n minus 1 times -3. Remember, it's multiple choice, so it could look like this. It could look like the -3 is distributed. So this would be 100 minus 3n plus 3. So this would be a sub n is equal to -3n plus 103. This one will not. So the general term will not be given, but the sum one will. So it's n over 2 times a1 plus an. So it asks us to find the sum of the first 25 terms. So what's our n going to be? 25, because there's 25 terms. N is the number of terms. What's our first term in our sequence? 100. And a sub n means that we have to find a sub 25. How do I find a sub 25? Plug it into our a sub n equation. So a sub 25 is negative 3 times 25 plus 103.
You're not getting that formula?
No. So this is negative 75 plus 103, which is?
1600.
Just for a sub 25
Oh, I think so. Yeah,
would be 28. So then to find our sum, 100 plus 28 times 25 divided by 2. So 1600. So two formulas that you need to add to your list of what you need to memorize for the test would be your general form for arithmetic and your sum for arithmetic. So let's look at 40. So 40 is an arithmetic sequence because it has the form like an arithmetic sequence here. So we can use the sum of an arithmetic sequence, which is this formula up here. So the sum is equal to the number of terms. So if I'm going from 1 to 11, how many terms do I have? 1, 2, 11. So it'll be 11 over 2 times the first term. So if I were to plug in 1 in here, I would have 2/3 plus 4, which again, we can use our calculator. So 2/3 plus 4, 14/3. Yep. And then we plug in 11 to find what our a sub n is. So that'll be 22 over 3 plus 4, which this would become 12 over 3. So 34 over 3. So we can add these together. We get 48 over 3. 48 is divisible by 3. We get 16, so 11 over 2 times 16, which would be 88. All right, let's look at 55 and 56. So these are geometric sequences. It's important to know what type of sequence you are working with before you start. So we're going to be multiplying by some number to get from one number to the next. So let's do 55. So what am I multiplying by 16 to get negative 8? Negative 1/2. So that would be my R. That's my common ratio. I need my formula for a geometric sequence, which would be a sub n is equal to a sub 1 times r to the power of n minus 1. This is another one that you guys need to remember. So this is your general term for a geometric sequence. What is my first term? 16. My r, we said, is negative 1/2. And then n is the number of term that I'm looking for, which here is the 6th term. So 6 minus 1. So a sub n is equal to 16 times, have to do 6 minus 1 first, so that'll be negative 1/2 to the 5th power. So we can put negative 1/2 to the 5th power in our calculator, and then multiply it by 16. So a sub n is equal to negative 1/2. So let's look at 57 and 59. So here we have to find the sum. Couple different ways we can do it. We can start by plugging in 1, plugging in every number that leads up to 7, but these are also geometric sequences because they have that exponent there. So they're pretty much the same. We can do 57. So our sum of this would be finite geometric sequence. So our first term we can find by plugging in 1 into our equation. So 1 minus 1 would be 0. What is 2 to the power of 0? 1. So a sub 1 is 1. 1 minus, what's our r? R is the number that has the exponent, so that would be 2. What is our n? N is how many terms we have from 1 to 7, so that would be 7. And then we have 1 minus r, so that is 1 minus 2. So we can put this into our calculator. We need 2 to the 7th power. 1 minus that would be negative 127 over 1 minus 2 would be negative 1. So this would just be 127.
Are we going to use logs in our final?